This video looks at the group 7 elements, what we call the halogens. We will split the video into two. The first part will look at introduction to the halogens and their physical properties, and the subsequent video will look at their reactions, reactivity, and uses. Okay, so let's look at the group 7 element. Now, the elements in the group 7 of the periodic table are also called halogens. They are also called halogens, and they include fluorine, chlorine, bromine, iodine, and astatine. Fluorine, chlorine, bromine, iodine, and astatine. Now, let's look at why they are called halogens. Now, these nonmetals are very reactive, and one fact about them is that they are toxic or harmful. Now, indeed, before the inception of antiseptic, iodine was used to clean wounds. Why? Because iodine is said to be harmful to all organisms, including bacteria. So in the absence of antiseptic, iodine could be used to wipe wounds, okay, to prevent infections. Again, the halogens are so reactive that they are never found free in nature because of the fact that they are very reactive, and they are instead found as compound with metals. All right. Now, these halogen metal compounds are salt, which give halogens their name, halogen. The word halogen itself means salt former. And so because the halogens or the group 7 metals elements react with metals to form salt, we call them halogen. Pay attention to the answer to this, because you may be asked in exams to explain why the group 7 elements are called halogens. Okay, now let's look at their electronic structure. In fact, all the group 7 elements have 7 electrons in their outer shell, and this has implication in terms of their reactivity. Now, what does that mean? Now, it means that they can easily attract one electron in order to form a stable outer shell, and in doing so, they form negative ions with -1 charge. Okay, and that also gives them similar chemical and physical properties. So the group 7 elements have 7 electrons in the outer shell. All right, and they can easily attract one electron to form a stable outer shell, and in doing so, they form -1 ion. Okay, so over here we have fluorine with atomic number 7, 9, with 2 electron shell, chlorine with atomic number 17 with 3 shells, and bromine with atomic number 25 with 4 shells. Now, this have implication with their reactivity, and we will look at them later on. Now, how do halogen molecules exist? Now, all the halogen atoms, we say that they have 7 electrons in the outer shell. Now, what that means is that they need 1 additional electron to obtain a full outer shell and become stable. Now, how do they achieve this? They do this by sharing electron with 1 other atom. Now, once they do that, they then form a single bond between them. So over here, you will see that fluorine has 7 outer electrons. It then go on and overlap with another fluorine, which also have 7 outer electrons. Now, in doing so, they share 1 electron between themselves and form a single covalent bond. Now, the implication of this is that the halogens always exist as diatomic molecules. They don't exist as single atoms. So we have fluorine F2, chlorine Cl2, bromine Br2, and iodine I2. So they always form single covalent bond between the atoms to form molecules in order to achieve a stable outer shell. Okay. Now, what are the properties of the halogen? Now, first of all, they are non-metals, and as such, they do not conduct electricity. The halogens are non-metals and therefore do not conduct electricity. They are also brittle and crumble when they are solid. And like I said before, they are poisonous and smelly. These are some of the physical properties of the halogen. Now, in terms of color, they become darker going down the group. Therefore, fluorine is pale yellow, chlorine is green yellow, bromine is dark orange, and iodine is dark gray. Okay, so their color get darker as you go down the group. Again, they are non-metals and so do not conduct electricity. They are brittle and crumble when solid, poisonous and smelly. Their color get darker as you go down the group. Okay, so pay attention to the colors of the individual element as you go down the group. Now, let's look at their melting and boiling point as you go down the group. If you look at this table, you will realize that the melting and the boiling point increases as you go down the group. They increases as you go down the group. So over here we have fluorine with melting point of minus 220 and boiling point of minus 118, chlorine melting point of minus 101 and boiling point of minus 33, bromine minus 7, and iodine 114. Now you realize that the melting point increases as you go down the group. It increases as you go down the group, and the boiling point also increases as you go down the group. Now, can you therefore state the state of these elements at room temperature? Are they liquid, gas, or solid at room temperature? Pause the video and write it down. What is the state of fluorine at room temperature? What is the state of chlorine at room temperature? Write them down. Okay, so you realize that because of their melting and boiling point, fluorine and chlorine are gas at room temperature, bromine is liquid at room temperature, and iodine is solid at room temperature. Okay, pay attention to that. Fluorine is gas at room temperature, chlorine is gas, bromine is liquid, and iodine is solid at room temperature. Now let's recap what we learned with some exercise so far. Are these statements about halogen true or false? 1. In their elemental state, halogen exists as monoatomic molecules. 2. The reactivity of halogen increases going down the group. 3. Halogens form negative ions. 4. All halogens are gases. 5. Halogens become darker in color down the group. And 6. Halogens have 6 electrons in their outer shell. True or false? I want you to pause the video and answer them on your paper. Pause the video and answer them in your book. All right, so let's look at them together. We've got number 1, in the elemental state, halogens exist as monoatomic. True or false? Of course, that is true. Question 2, the reactivity of halogen increases going down the group, true or false. That is false. 3. Halogens form negative ions, true or false. That is true. 4. All halogens are gases, true or false. That is false, because we just look at the table where the iodine was solid. 5. Halogens become darker in their color down the group, true or false. That is true. And halogens have 6 electrons in their outer shell. That is false. They have 7. All right. So that is about the introduction to halogens. Now, how do halogens react with metals? We learned with the group 1 that they react with metals to oxygen to form metal oxide. Let's look at how the group 7 react with metals, or react specifically with the alkali metals. Now, the electronic structure of the halogens means that they react vigorously with the alkali metals. Now, halogens need to gain 1 electron for a full outer shell, and alkali need to lose 1 electron for a full outer shell. This means that halogens and alkali metals react to form ionic compounds, and these are metal halides, which are a type of salt. Now, what are we saying here? The halogens require 1 electron in order to obtain full outer shell. Remember that we said they have 7 electrons in their outer shell, and the alkali metals have 1 electron in their outer shell, which they want to get rid of in order to form a stable outer shell. Now, in doing so, it becomes easier for them to marry together. 1 needs 1, 1 wants to get rid of 1. So they do that to form ionic compounds. Now, a common ionic compound between a halogen and an alkali metal is sodium chloride, right? Now, can you name any other ionic compound between a halogen and an alkali metal? Pause the video and write it down. So one common ionic compound between alkali metal and a halogen is sodium chloride, common salt. Okay, now this is metal halide. This is a metal halide. It's a combination of metal and the halogen, so we call it metal halide. Okay, so the halogens react with alkali metals to form metal halides. Now, how do we get metal halide? How do we get metal halides, or the halide ion? Now, when the halide atoms react with any substance, they form negative ions. Now, how do they form negative ions? By gaining an electron. We've already established that. Now, when this happens, they are called halides. Okay, the name of the halogen changes once it has reacted, and instead of ending in INE, it ends with what? IDE. Now, what are we saying here? Now, we know that the halogens react with the alkali metals. When they do that, then they become halides, and their name changes. Instead of ending in INE, they end in IDE. Now, so over here we have fluorine. When it reacts with any metal, it then forms fluoride. Chlorine becomes chloride. Bromine becomes bromide. And iodine becomes iodide. Okay, so pay attention to the formula. F minus 1, Cl minus 1, Br minus 1. This is the halide. Okay, and they become halide by gaining an electron. Okay, so if we take an example like this one. We have sodium chloride, and the chlorine here, this consists of what? Sodium 1 plus and chlorine 1 minus. This is the halide reacting with what? The metal. Okay, so this is called sodium chloride. In this case, it's ending in IDE instead of INE. Now, if sodium reacts with chlorine to form sodium chloride, what are we going to get when potassium reacts with chlorine? Pause the video and write it down. Of course, we are going to get potassium chloride. Okay. Now, forming halide ion. Now, for the high tier student, you should be able to write the half equations for the reactions. Now, for the chlorine, what is happening to the chlorine? Remember, we said that chlorine was getting electrons, gaining electrons, and therefore it's being reduced here. So the chlorine gains 2 electrons here and become chloride ion over here. Learn how to write the full ionic equation with the full balanced ionic equations. Okay. The gain of electron is called reduction. Remember, we did this with the acronym oil rig. Okay, oil rig, which means that oxidation is loss of what? Electron. Reduction is gain of electrons. Okay, so over here, because chlorine is gaining electron, chlorine is being reduced to chloride ion. All right. Now, equations for halogens and alkali metals. Remember, we said that the halogens react with the alkali metals to form metal halides. And I gave you an example of a reaction between sodium and chlorine. So over here we have the word equation, chlorine plus sodium. You're getting yourself sodium chloride. Now learn how to write a full balanced chemical equation between the two. Now what about bromine? Bromine with potassium will give you potassium bromide. Write the full chemical equation down. This is the word equation. Write the full chemical equation down. So we have Br2 plus 2K to give you KBr potassium bromide. Make sure you can balance the equation. Now, what are you going to get if iodine reacts with chlorine? Write the full word equation and balance equation down. What are you going to get if chlorine reacts with iodine? Now, let's look at the electronic structure of the group 7 and its effect on their reactivity. Now, the reactivity of the group 7 element decreases going down the group. It decreases going down the group. Why? Now, this is because of the electronic structure. Now, in terms of why the reactivity decreases going down the group, you have to explain it in line with the size of the atom getting bigger going down the group, similar to the alkali metals. Now, in this case, we are saying that the atom of each element get larger going down the group. Okay. Now, what does that mean? As you go down the group and the size of the atom get larger, what implication does it have on their reactivity? Now, what we are saying is that as the atom's size gets bigger, the outer electron gets further away from the nucleus and is shielded by more electron shell. The further away the outer shell is from the positive attraction of the nucleus, the harder it is to attract another electron to complete the outer shell. Now, what are we saying here? Now, if you look at these three elements, we have fluorine, chlorine, and bromine. Now, fluorine have only two shells. It has this outer electron. Chlorine have three shells and another outer electron. Bromine has four shells and another outer electron here. Now, what you realize is that now in fluorine, there is no electron or shell shielding this outer electron from the nucleus. Now, if you come to chlorine, you see that there is these shells here with electrons blocking the outer electron from the nucleus. As you go down, the shells keep increasing in number and therefore reduces the influence of the nucleus on the outer shell. Okay, now this means that it becomes harder for the positive nucleus to attract an electron to complete the outer shell in order to obtain a stable shell. The easier it is for the nucleus to attract electron to complete the outer shell, the more reactive the element. So you realize that over here it is easier for fluorine to attract an electron to complete the outer shell in fluorine than in chlorine, and it's also easier in chlorine than in bromine, and that's why reactivity increases going down the group. It becomes difficult as you go down the group to attract an electron to complete the outer shell. The more easier it is to attract an electron to complete the outer shell, the more reactive the element. Now, as you go down the group, it becomes difficult to attract electron to complete the outer shell because of the increasing number of shell, which shields the outer electron from the positive nuclei. So pay attention to this explanation. Questions are normally asked around this. Now, what is the reactivity of the halogens? Again, you will look at the Wu experiment to establish the reactivity of the halogen, to establish that it decreases as you go down the group. And so if you do the Wu experiment, you realize that if you react chlorine with iron Wu, the iron Wu bends and grows brightly. If you react with bromine, the iron Wu grows but less brightly than in chlorine. And also if you do that with iodine, the iron Wu has a very slight grow. So you see that reactivity decreases as you go down the group, because as you go down the group, the size of the atom increases, the number of shells increases, the shielding effect of the outer shell is shielded from the positive nucleus, and therefore it becomes more difficult to attract an electron to complete the outer shell, resulting in less reactivity as you go down the group. Now, how do the halogens react with non-metals, especially hydrogen? Let's look at their reactivity with hydrogen. Now, the halogens react with hydrogen to create hydrogen halides. Now, remember we said that they react with alkali metals to form metal halides. Here, we are saying that they react with hydrogen to form hydrogen halide. Now, so you look at here, we have hydrogen with a lone pair or a lone electron in its outer shell. It needs one more to form a stable outer shell. Now, the halogens have 7 electrons in the outer shell. They need one, okay, to form a stable outer shell. What happens is that because the hydrogen needs one, the halogens need one, they therefore share electron each, and overlap and share electron, creating a covalent bond between them. Okay, and in doing so, they form what we call the hydrogen halides. So here there is a covalent bond between hydrogen and chlorine to form hydrogen chloride. Now, what property of the hydrogen halide is that they dissolve easily in water. Okay, they dissolve easily in water and form strong acid. So if you dissolve the hydrogen chloride, can easily dissolve in water to form hydrochloric acid, which is a strong acid. Okay, so there is a covalent bond between the hydrogen halide, between hydrogen and the halogen to form hydrogen halide, and they are able to dissolve in water to form strong acid. In the next video, we will look at the reactivity of the halogens.